Well, today we'll deal with activity 4. Okay, so in this activity we'll take metal carbonates. On the other hand, we'll take one more, that is metal hydrogen carbonates. Okay, for example of metal carbonates, we'll take Na2CO3, sodium carbonate this is. On the other hand, we'll have metal hydrogen carbonate, we'll take sodium hydrogen carbonate. Okay, now when this metal carbonates get reacted with acid, okay, what it is going to happen, and when this metal hydrogen carbonate is reacted with an acid, what it is going to happen, right? So for this activity we'll take two test tubes. Let's consider this is test tube. Okay, there is a bend. Wonderful. Okay, let's name it as A. We'll take one more test tube here. Okay, let's name this thing as test tube B. Okay, we have two test tubes. In the first test tube we'll take an acid, and that acid is nothing but HCl, hydrochloric acid. In this test tube also we'll take HCl. Wonderful. Okay, and we'll add Na2CO3, that is nothing but sodium carbonate here, and we'll also add sodium hydrogen carbonate here. Now what might be going to happen is, when metal carbonate like sodium carbonate that gets mixed with acid, what happens is there is a form of salt, that is nothing but sodium chloride is formed. Okay, salt and some amount of water gets released. Okay, and a gas that gets released is carbon dioxide gas released, right? Now if you look into this, what happens is there is a salt, the salt is sodium chloride, and water is liberated and carbon dioxide gas is evolved. In this case also, if we consider this case NaHCO3, right, when it is get mixed with HCl, we consider these two. This case also we got a salt, water and carbon dioxide gas is released. Okay, wonderful. If you consider these two cases, the products are same, yes or no? Okay, here if you observe these two cases, let's balance them. In the reactant side, sodiums were 2, carbon is 1, oxygens were 3, hydrogen is 1 and chlorine is 1. Here also sodium is 1, chlorine 1, hydrogen is 2, oxygen 1 and oxygen 1, overall 3, and carbon 1, right? So if you do here, let's add something. I think we need to balance 2 hydrogens and 1 chlorine. Okay, here 2 sodiums, let's put 2 here and let's put 2 here. Now try to balance it now. Now in this case we got 2 sodiums, 1 carbon, 3 oxygens, 2 hydrogens, 2 chlorines. Okay, let's see this. 2 sodiums, 2 chlorines. Okay, this is balanced and this is balanced and this is balanced. Wonderful. Chlorine also balanced. Coming to the hydrogens, 2 hydrogens balanced, hydrogens balanced, oxygens were 3 balanced and carbons were 1 balanced. Okay, this is overall a balanced chemical equation here. Now in this case what happens is, when metal carbonate gets reacted with acid, we got a corresponding salt, because we had taken a sodium carbonate, right? We got a salt that is related to the corresponding metal. So sodium chloride gets deposited at the bottom of the flask, and okay, and water gets liberated and a gas is evolved, right? So if you look into this case, right, so let's observe sodium. Here sodium is 1, in this case also sodium is 1. Wonderful, no need to balance it. Okay, these two are balanced. Hydrogens 1 and 2 hydrogens. Here hydrogens were 2. Wonderful, there is no need to balance it. Carbon is 1 here. Here also carbon is 1. Wonderful, balanced. Oxygens were 3. Wonderful. Here oxygens 1 and 2 3. Wonderful, 3 balanced. Coming here, remaining is chlorine, it's 1. Here also chlorine is 1. Okay, so no need to balance it. So everything is balanced here also. It is also a balanced chemical equation. Wonderful. Now in this case also, if you observe here, when metal hydrogen carbonate gets reacted with an acid, what happens is we got a salt, water and carbon dioxide. Wonderful. Now as I said here, said something, that is carbon dioxide gas gets liberated, right? So in the previous activity, as I said, when H2 gas is evolved, we need to do a test. Yes, you need to check whether the gas evolved is H2 gas, right? You need to send that gas into the soap or solution, and then the bubbles get evolved, right? And you need to put a candle over here. Now what happens is the candle puts off with a pop sound. If that candle puts off with a pop sound, we'll consider that gas is H2 gas, right? Now we also have a test to check whether the gas evolved is carbon dioxide or not. Now we'll put a cork. We'll put a cork here also. Wonderful. And we'll put a delivery tube, and that delivery tube, okay. Now what happens is here sodium chloride, it is in solid form, gets deposited at the bottom, and water, okay, it is also remains there, but carbon dioxide is in a gas form, right? So it just wanted to escape from this test tube, so it comes out through this delivery tube and comes inside this test tube, right? So inside this we'll take one thing, that is nothing but a lime water. What? Lime water, that is nothing but calcium hydroxide. What it is? Calcium hydroxide. Another name of calcium hydroxide is lime water. When the gas liberated gas, okay, gets immersed inside the test tube, okay, wonderful. When it is evolved inside the lime water, what happens is, look the equation here. Now when calcium hydroxide is just added with carbon dioxide, we got a very special thing, that is nothing but CaCO3, that is nothing but calcium carbonate, okay, and some amount of water gets evolved, right? CaCO3, okay, it is nothing but calcium carbonate. Now in this case what happens is there is some deposition of something happens here, so that is nothing but white precipitate is formed, white precipitate, okay. Now after this happens, what happens is the carbon dioxide is still coming out, right? So the process goes on. Now what happens is this calcium carbonate again reacted with carbon dioxide, okay, this calcium carbonate again reacted with carbon dioxide, we got calcium hydrogen carbonate, okay, calcium hydrogen carbonate, CaHCO3 taken twice, okay. So this is milky white color, okay. The overall solution gets turned into milky white color, in this case also, in this case also. Now the major difference between these two is, when CaCO3 is formed, okay, the white precipitate get deposited at the bottom of the flask, right? It is not, okay, it is not soluble in water, so it is not soluble in water. But when this calcium hydrogen carbonate gets formed, it gets mixed with the water, and we got an overall milky white solution, right? So that means this calcium hydrogen carbonate is soluble in water, okay. You need to remember these two cases, they might ask you in examination, okay. Is calcium carbonate is soluble in water? No, it is not soluble in water. Is calcium hydrogen carbonate is soluble in water? Yes, it is soluble in water. Then what is the color of the solution? Milky white color, okay. You need to remember this thing, right? So this is the overall equation. Now they might ask you in the examination about this activity 4 is the word equations, right? What were those word equations? That is, when metal carbonates reacted with acid, what happens? We got a corresponding salt, water and carbon dioxide. When metal hydrogen carbonate reacted with acid, what happens? Yeah, same thing happens, that is corresponding salt, water and carbon dioxide gas evolved, okay. Then they might ask you in the examination that what is the test to check whether the gas evolved is carbon dioxide or not. Yeah, the test is very simple. You need to send the gas to the lime water, and that what happens is when carbon dioxide reacted with lime water, we get a CaCO3 and some water evolved, right? Now this carbon dioxide again reacted with this calcium carbonate, then what happens is we got a final product, that is calcium hydrogen carbonate. It is soluble in water, so the overall solution gets turned into milky white solution. Then we easily say the gas evolved is carbon dioxide gas, right? Is it clear? Wonderful, right? So this is about activity 4. Okay, in the next class we'll deal with activity 5. That was very important. Okay, don't miss that class. Thank you.